Awesome. Okay, here is our organic chemistry exam. I want to let you guys know that I have made quite a bit of changes to the marking schedule, and I have made notes on it, and the digital copy that I have online has those notes on there. The reason why I did that is because I felt there were some things that were definitely very tricky questions. It was definitely a hard mock exam. So I adjusted the marking schedule accordingly to kind of give that flexibility to give you guys some points, because it was very different to what you guys were used to. So do kind of keep that in mind. It's useful to see stuff like this because every so often NCA throws a curveball because they're trying to be creative and giving you a new question. So that's why we kind of make sure that in our mocks we give you stuff that looks wonky. Cool. So let's start with question number 2 because that was the most requested question. Even though it was a hard exam, there's aspects of it that I really, really enjoyed. Because I think it does actually test well your chemistry, or organic chemistry understanding. So, does everyone have their mocks or a blank mock? Cool, I'm going to run through it. Blank one? Yep, I can do that. I know some of you guys would like to have blank ones just to scribble on as extra notes. Cool. So, first question was our triglyceride question. This is very common. I think even No Brain Too Small might collate the triglyceride questions together. And the reason why triglycerides are often asked is because they have this ester component. So all of the material that you guys have learned on esters can be asked through this triglyceride question. So don't be surprised when you see a molecule like this. This first question here was that was really good in just making sure if you knew your identification tests. So, describe a chemical test to show that the triglyceride is unsaturated. Explain any observations and state the type of reaction occurring. This was basically a really clever way for them to see if you knew your vocabulary. So if I see the word unsaturated, what that means is that there's a double or a triple bond. My carbons aren't fully maximized to the bonds that they can have. So what it was asking you for is, can you tell me how you identify that alkene in that molecule? The thing is, I found a lot of you guys were thrown off by that question because there was so much else going on. So kind of keep that in mind. But that one was a really straightforward question about using bromine water and how that's going to decolorize and that it is an addition reaction. They will also be willing to accept if you're using permanganate, but this one would be an oxidation reaction or redox reaction would be fine. So this one did go up to the merit level because you needed both the observation and the type of reaction. A lot of you guys didn't read the question and forgot to write down it's an addition reaction or it's an oxidation reaction. So that was your first one here. The second one here was talking about the triglyceride undergoing hydrolysis reaction. So hydrolysis is the important part here. And it's doing this in aqueous sodium hydroxide. Again, read the question and the scope of it, because some of you guys gave me some extra answers that you really didn't need to give me. So since it's sodium hydroxide, we're doing hydrolysis in basic conditions. Are we good so far? All right. Now, it asks you to draw the product for all. It asks you to draw the structural formula for all of the products formed. A lot of you guys made some really silly mistakes when it came to drawing these organic products. So let's go back up to the triglyceride. So when we are doing hydrolysis, the hydrolysis is occurring with the ester. So the break point that you were looking for, so a lot of you guys broke it very strangely. A lot of you guys assumed it was breaking like this and breaking here and here. No, it's ester hydrolysis. So you're looking for the ester, and the ester point is where it's breaking. It's breaking right there. You should have 4 molecules written down because you would have the triol, because that's still connected together. There's going to be a hydrogen added to each one of those. So that's your triol. That was one of your products. And then the other three products were all carboxylic acids. There are 3 different chains. There's no repeated chains. The thing that a lot of you guys might have missed is that says 11, that says 13. So those are 2 different chains. And then this one here was your weird, wonky, double bonded chain. A lot of you guys forgot one of these 3 guys when you were breaking the molecule down. Are we okay with that so far? So that's how you'd break up my ester. The other thing to remember is that since this is in basic solutions, we needed to show the carboxylic acid neutralized. So you should have been doing your C double bond O with the minus sign, neutralized with the sodium ion. All right? So looking at the marking schedule here are your 4 different products. I changed the marking schedule because I noticed you guys really struggled with this. So I adjusted it to just be like, look, if you understood that there was going to be a carboxylic acid and an alcohol being produced, I gave you an achieve point. If you did it correctly, but you had a partial error, let's say you forgot to neutralize the carboxylic acid, I was still willing to pass you on it because I didn't need it perfect. The thing that I noticed is that a lot of you guys were struggling to get all 4 because you're just making silly mistakes. And so again, I was being generous. So what I changed it to was you need to get 2 products right or 3 products right with a slight error, but otherwise 2 perfect ones. And then what I did was I put all 4 being correct as part of the excellence point that I was creating, or not creating, adding to. Because this excellence point didn't have anything about the products being formed. And I thought, you guys usually don't see 4 things being formed with your hydrolysis. So that's why I kind of moved the points around. Okay? Trying to make it fair. So you guys okay with that one here? All right. Next one here was just your equipment question and apparatus setup. This here is a reflux. A lot of you guys, it was just a simple mistake in your vocabulary and swapping around reflux and distillation. You got them just wired the wrong way in your head. Make sure you know what reflux looks like and what distillation looks like and what they are used for. This is a reflux. The reason why I know it's a reflux setup is because I don't see an exit tube. Be mindful that these water in, water out tubes are the outside of the tube, and the inner tube is actually shielded. So none of this product is actually exiting through these little holes. Does that make sense? It's all stopped. You see there's a stopper there, and all of that's preventing it from leaving. We good? All right. So let me talk about the layers that I was looking for this answer. So if you gave me 1 correct statement, you were able to get an achieve point, and that was 1 correct statement regarding the reflux setup. For the merit, you were allowed to get it if you had your products and you had an incomplete justification for it. So basically what I was looking for your complete justification, again, I was really flexible with it because I thought the marking schedule was a little bit harsh. There are 2 reasons why you need to be thinking about using reflux. The first reason is you're heating it, and that's going to increase the rate of reaction. I then put in little brackets because I wasn't too harsh if you did or didn't have this point. But what you were thinking about was, we want to increase the rate of reaction without losing any of our reactants. So I could have a beaker set up and heat it and increase the rate of reaction, but the problem is things are going to evaporate away. If I use a reflux setup, I trap the vapors, and then the vapors have to go back down into the container, so I don't lose anything when I do this. So that was the first reason, and that's kind of the full layered answer they're looking for. The other reason that we were looking for reflux is we want to do it to increase our yield. You could say increase to 100% of the reaction completion. Without losing any products. Again, that reflux is important because it traps everything. So I won't lose product, I won't lose reactant, I'll make the reaction go faster, and I'll get a higher yield. Cool? Again, I thought all these little details that they were wanting was a little bit hard, so I was a little bit more flexible for it, but you have to also keep in mind the vapors are condensing back down into the conical flask. Okay? So basically, for the excellence, I was looking for the digistate increased rate of reaction and digistate yield. For the merit, I was willing to take if you had one justification. Thus the incomplete. Does that make sense? Grace?
Yeah, I'm just
thinking what your answer is. Yeah, and if there's something wrong, let me know, because it's the last couple days have been a blur.
So if we're going to get the excellence, it's including the getting over for hydrolysis.
Yeah, that's what I added into it because since I was making the justification bit a little bit more flexible and easier, I then put in the 4 molecules from the hydrolysis need to be right. Yeah? All right, this one here is your amino acid, and let me tell you, that was a nightmare of an amino acid to give you. I am so sorry. Okay. Also, this question here, you guys have never seen before, and I was like, oh no, that's not fair. So I was, again, very flexible with this question because you guys haven't seen it before. The thing here is that you were identifying the features that make things enantiomers, so just the chiral carbon thing. And then they wanted to know, state the number of this and this enantiomer that leucine has. And I think you guys have never seen those 2 words before. I haven't seen those 2 words before. So I thought that was kind of ridiculous. When I read the answer, it made sense. So I'll put the answer down so you guys can see it. The reason why, so gave you the chiral carbon definition, yada, yada, yada. The reason why it has 2 of each, aka 4 different enantiomers, is because we have 2 chiral carbons. So that was the answer to that one.
But how are we supposed to know that if we don't know?
That's why I was very generous with that question, because I was like, that I have never seen before.
Also, the answer is like a combination.
Yeah, so this one has a version, that one has a version. Yeah, that's what. So
It makes sense.
it makes sense.
Is that something that asks in uni?
I haven't seen it. I don't know why it was there, but that is I was flexible. So what I did was a correct definition and number of enantiomers. I just crossed it out and I said, look, if you stated 2 enantiomers, because that's what you're used to doing, I was going to give you an achieve point. We'll talk about the merit section here. What I did then is I created an excellence point if you did manage to say there's 4, which some people actually did figure out. So there was a bonus excellence point because I thought that was really nasty. We good with all of that? All right. Next one here is joining together your dipeptides. A lot of you guys got real messy and confused, and I don't blame you for getting real messy and confused because the amino acid we gave you was not a friendly-looking amino acid. Do you guys want me to draw it out, or are you just happy with me just showing you the image of what it looked like? And even there, it still looks like a nightmare.
I think the one that I did.
Do you want me to draw it? Yeah, Angel's saying yes. Okay. So, I hated this too because I needed to really kind of think about it. Let's start with always doing our amide bond. Carbonyl, nitrogen, nitrogen, there. Okay? That helps me set it up because that's going to be the bridging point between my 2 amino acids. With these amino acids, you're doing 2 of the exact same one because they've only given you 1 amino acid. So that's what my dipeptide is going to look like. So we're going to draw one first, and then we'll draw the other one. So since this one's taking my carboxylic acid component, that's been drawn. So then I draw this carbon here, which has the nitrogen, so the amine group here. Then it has the hydrogen, and then I draw the chain guy. CH, CH3, CH2, CH3. It's a little... See what I'm saying? It's a really nasty one. What you need to check for in each one of your amino acids is, do you have a carboxylic acid component and do you have the amine component? And you're making sure that you're lining everybody up correctly because a lot of you guys put your amines in weird spots because it was a weird amino acid. It was a very hard amino acid. Hopefully they won't give you something like this. Are you okay with that? Should I draw the other half? All right. In this half, I'm starting with my amine. I have my carbon here. I see that there's a hydrogen here. And then I'm going to go carboxylic acid, like that. So all of those guys are done. So this carbon's here, I got it. This hydrogen here, I got it. This amine's over here. And then this carboxylic acid's coming off. Then, oh, sorry, over here is where that carboxylic acid's coming off. And then I can start doing this other chain. So this chain here, I've done that carbon. So now I'm moving on to this carbon. I'm doing the CH3, CH2, CH3. You guys okay with that? Yeah, it was a nightmare of an amino acid. I'm really sorry. I think I might change it next year and put a simpler one in there. Cool?
We're used to having carboxylic acid.
Huh?
We're used to having the carboxylic acid.
Yeah.
Different.
Yeah, you're used to seeing a much simpler, cleaner looking amino acid. This was a dirty amino acid that was like all over the show. So it was really hard to find things and then make sure things were placed correctly. So I was pretty, like I said, generous with this as well. Let me show you what I mean. So with the marking schedule, I said circled the amide bond and gave me like an amino acid or the dipeptide drawn with some sort of minor error because I was so mindful that this was just a nightmare of an amino acid. For the merit point, you needed to get basically this justification right and draw on the amino acids correctly, or sorry, the dipeptide correctly, and then for the excellence, it was all of that plus you stated the number 4. So, because I did create an excellence point for it because I thought it was a really hard question. Are you guys okay with that? All right, cool. Then they had a question here about hydrolysis again. No surprises there. And with this hydrolysis, you have the amine, the dipeptide bond above. You have aqueous hydrochloric acid and aqueous sodium hydroxide used to hydrolyze the peptide links. Describe hydrolysis and compare and contrast acidic and basic hydrolysis with the dipeptide and the formulas that are being formed. Very, very standard question. Nothing unusual about that, but some of you guys had a hard time with it. The main thing with this one here was just giving me the definition for hydrolysis. You're using water to break apart a molecule, and then layering extra information about acids and bases. So saying, that with acids, what part of the amino acid is getting neutralized, and the bases, what part is getting neutralized. Does that make sense? This section here was really important because that was you showing your evidence. And just to kind of show you what I mean, that these exam questions that we buy are very frustrating because sometimes they have mistakes in the marking schedule and mistakes in the exam. So, in the marking schedule, surprise, surprise, they have given me the answer for the hydrolysis of the ester from the question before. And I was like, were they supposed to draw the ester? I went back and I read the question again, and it very clearly stated they wanted you to hydrolyze the dipeptide, because I was looking like, you should have 2 products here. I'm like, no, they shouldn't. They should have 1 product because these peptides are exactly the same. There was no point in you repeating it. It was the same dipeptide. If they were 2 different dipeptides, I would want both of them drawn. But since it's the exact same... Sorry, if there were 2 different peptides, I'd want both of them drawn. But since there's only 1, I only wanted 1. So I did adjust the marking schedule to fix that error. So when it came to the hydrolysis, the main thing I was looking for, and what I was looking for in your justification, was just showing me that you knew which side was going to neutralize. I'll just go off the main image and save ourselves some time. So if I was doing acid hydrolysis, I am providing hydrogen ions, yeah? And so we are neutralizing the base component. So what I should see is you should have drawn this amino acid, you should have changed this number to a 3, and you should have added a positive sign there. So that's what you should see in acid hydrolysis. The carboxylic acid stays the same, so you do nothing to this. We good? All right. Oh yeah, go for it, Grace.
Can we still add
You can. So if you want, because it does tell you it's hydrochloric acid. If you wrote Cl minus next to it, I wouldn't be too fussed. But I wouldn't be fussed if it was there or not, sort of thing. Cool. All right. So if we were doing basic hydrolysis, remember you are removing hydrogen ions. And we're removing them from the acid. So in the basic version, this is not a 3, it is a 2. So you leave this alone. And for the carboxylic acid, the hydrogen's lost. You put a little minus sign, and then you show it being neutralized by that sodium, because it said sodium hydroxide. Sorry, it's a bit messy, and both of them are kind of written in one spot. Yeah.
The color question for technical reasons
Is it? Is it?
switch around to all acids.
Oh, that's similar enough. That wouldn't be a huge deal.
Well, no, it's important because the difference in melting point. Because this has a higher molar mass but a lower melting point.
But these are all very similar. The main thing that you're trying to compare is the butyric acid. That one's dramatically different. That's what it's trying to say. Alright, are we okay with that? Anna? Yep. Yep.
And I'm the only change in adding the butyric acid hydrolysis.
Yep.
Is that I'm adding a 3 to it and I'm
Yes.
and I'm
Adding a positive sign to it.
I'm not putting any other products in it.
No, because that's the only thing that's neutralized.
Yeah.
Yep.
But I'm not like in some of the new like plus
So you do that for the base hydrolysis.
So sorry, what am I doing with the base hydrolysis?
You're adding the sodium. Because the sodium is attracted to the negative. There?
NH2 and O minus.
Into the
Yeah.
with the H's.
Yeah. Cool. Yeah, but it depends on the marking schedule. It depends on how harsh they are. They probably would forgive it if you didn't put your sodium down. So long as you show that you know it's a salt, Anna. Let's see here they haven't put down the sodium for that base neutralization, but here they have. I don't think it's something they're going to split hairs over. Yeah. Cool. All right, that was that question number 2.
Oh my god, this is my favorite question of the exam.
Which one, 3?
Yeah, I love that one.
Yeah. It's interesting. None of you guys, like, with the scaling, like, 9 people or 90% say, please go through question 2. 70% wanted me to go through question 1, and only 40% wanted me to go through question 3. And I think it's, like, to be honest, looking at the scores, the question you guys did the best on was question 3.
Yeah, I got you.
Yeah. You guys really, like, you have practiced that, like, you hated these questions at the beginning because you're like, I don't know what I'm doing. But you guys got this one fine.
That's because there's one of these and then turn one thing into another thing again.
Yeah. So it was really good. They paired those 2 questions well. You guys did really well in that question. All right. I'll go through question 1 first, though, because that's the one that was ranked higher. All right. This one here was just your real basic identify your functional groups. That's all. I don't really have much else to say than that. This is very common again. It's going to be, they'll give you a complex molecule, and they're going to make sure, do you actually know how to identify functional groups when they're inside something? They're still the same functional groups. Okay? This one here was just your naming question. I was quite generous with this one, because I noticed on the marking schedule, it said, you had your acid chloride, but in fact, it was the acid chloride and there was a chlorine, so a haloalkane. So I was willing to accept it if you wrote haloalkane still, because you've identified one of the functional groups. I didn't like that as an idea. But most of you guys were fine on that one. The other thing that was quite common is for butane 2-on. A lot of you guys dropped the AN. I was willing to forgive that when I was marking it, so that's why you see on the merit I have, really minor error for 1, and that was to allow for that one to kind of breeze on past. It depends on the suffix.
Yeah, that shouldn't have been what
That's what I thought too. I was like, all you're doing is identifying functional groups and naming and drawing. That is not an excellence point. So I have taken the excellence point away there. but I put an excellence point in elsewhere. So everything's still fair.
Sorry, you did mean the AU? You did.
I was willing to forgive the AN for merit points because it's so minor.
So that in future,
You need to have it.
you need to have it.
Yeah, yeah. I was being kind when I was marking it, but the examiners probably won't be. All right. Oh, my earring just fell out because I was playing with it. It's fine. I'll screw it. There we go. Okay. I'm trying to think what else I wanted to point out to you guys for this question. A lot of you guys had an error for this one here when it came to the naming because you numbered it twice. You can only number it once. 1, 2, 3, 4. A couple of you guys called that 3-chloro. Or sorry, a couple of you guys called it 3-chloro because you're going 1, 2, 3. Right? Wrong. Number it once. The last one in the naming, a lot of you guys just forgot the methyl. This guy. I don't know why. You didn't see him. It blended in. And I circled it and I was like, that's ridiculous. That one I wasn't willing to give you a merit point for. That was not minor. That was pretty major. The other thing that I noticed in a lot of you guys is the 1,3-diol. A lot of you guys were also putting it as a suffix, but you put it as a suffix with the diol. So you said in the beginning 2-methyl, 1,2-diol pentane, which is not how you name it. If you're doing it as a prefix, it's hydroxyl. If you're doing it as a suffix, it's diol.
So it would be 2-methyl, 1,3-hydroxyl propane.
Dihydroxyl, yeah. So if you're doing that, that's how you're supposed to do it. And then same thing here. A lot of you guys were doing some weird alls here. You're like 3-all butane 2,1. Again, the prefix version is the hydroxyl. The suffix version is the all. You can use either or, but you need to make sure that you grab the right word. Okay? Lots of silly mistakes there because of that. Cool? Keep going? Alrighty, I'm just watching the time. So next question here was to circle the enantiomer for the 2-chlorobutane oil chloride. That was a pretty mean question because if you had misdrawn that molecule, it snowballed and affected the rest of the question. Most of you guys were okay. A lot of you guys also just forgot to circle the chirocarbon because this is like at the bottom, missed it. Yeah, and when you see the original question, it said you needed to get both this and the isomers drawn correctly for the merit point. And I was like, so many of you guys just didn't read this bottom bit here, but you clearly knew which one was the chirocarbon because you drew your enantiomers correctly. So long as you drew your enantiomers correctly, I gave you the merit point, even if you forgot to circle it. With this one here, for the achieved point, chirocarbon needed to be circled and one correct 3D image, or maybe you drew the isomers, but you've done something weird and made a mistake. So I was willing to accept isomers that were mistaken if you had misdrew the molecule, but when you misdrew the molecule, you identified a chirocarbon from that misdrawn molecule. So I was willing to forgive that, but only for the achieved.
Well, what they should have done is move this to the top of it and then fold it on the line.
So that's why I was forgiving it. All right. This one here was 2-chlorobutanol chloride is a liquid at room temperature. Identify 2 physical features that are the same. Again, this threw you guys off because you guys went on autopilot for enantiomer answers, and you talked about plain polarized light. Grace.
So, what would the physical properties look like?
That's what I'm going to answer. So, melting and boiling point, density, weight.
I think about that it's an acid.
Yeah, I was willing to forgive that because I was like, that's not a great one. Because again, it was very different from what you guys were used to, so I was very flexible in what I was willing to take. So melting point and boiling point were the obvious ones. You use a thermometer, you just see if they freeze at the same temperature. You can check density. It's like you check the mass of it. That sort of thing. They technically weren't going to accept solubility as one of the properties you could check because it's an acid chloride. When you put it into water, it's going to react violently, so that doesn't really help you. I was willing to accept that because I didn't think you guys would make that next logical step. I thought that was really ridiculous. So I still accepted solubility as an answer. I also accepted if you just said it would have acidic properties or to react violently with water, because that is a property of it. So I was generally pretty flexible with it. When it came to the points, again, I tried to make it more flexible. So 2 physical properties, I was really generous with that. If you said something like same formula, or you said they're going to be mirror images, technically the mirror images are different and not the same, but like you're trying to name physical properties, so I was going to give it to you. For the merit then, I changed it to only being 1 identification test instead of 2, and I said I will take the polarized light regurgitation autopilot answer because you guys are so used to giving it. Just be careful, read the question because it's, yeah. I then created your excellence point here because not many people actually read the question properly and said if you explain 2 tests for properties, I was going to give it to you.
Oh, they didn't ask us for how to differentiate.
They did not ask you about how to differentiate anomers. And yet everybody wrote about it because you guys were on autopilot.
That's pretty funny.
That was pretty funny. It was also pretty frustrating. So you might see in a lot of your papers that I circled the word same. We're trying to prove they are the same. Read the question is the advice that I have for this one. All right, just watching the time. We might not be able to get to question number 3, but that's okay. I think also I'll post the answer keys online today as well because I think we're ready for everything to go out. All right, this here was your identification question. It should have been an easy one,
This is such a main question.
but you guys didn't use the bullet points, so you didn't get your full points because the marking schedule was quite harsh with what they were going to take. So, again, the weird thing in this marking schedule is that it did not include the oxidants like permanganate and dichromate. I have added it into the marking schedule, and I accepted those answers because those are ways to identify these molecules. That was all fine. The thing that kind of let a lot of you guys down were type of reaction. A lot of you guys forgot to state that this is an oxidation reaction, this is an addition reaction, this is a substitution reaction, and then I couldn't give you the full points. The other thing a lot of you guys forgot to do, equations. So this was, like, you guys got low points on because you didn't use the bullet points. Okay?
I forgot the 2 proper tests for distinguishing. And I was like, okay, well, oxidizing wax.
You guys know it's overcomplicate things too. The bottom one was a nice tricky one because that was your secondary and tertiary alcohols. You could have used Lucas reagent as a substitution reaction. It would go cloudy. This one would be fast. This one would be slow. But if you used an oxidant and you said the aldehyde goes to a ketone and sorry, not the aldehyde. The secondary goes to a ketone and the tertiary won't react, I still accepted that because that is an identification test for it. The main thing, though, is that when it came to how the points were broken down, achieved 2 correct reagents, 2 correct 2 correct observations, or you had 2 correct reaction types, or, and I started to add an extra ors to give you guys points, 1 correct reagent, observation, and type of reaction. For the merit, you needed 3 substances distinguished, reagents, and observations. This is what really hurt you guys. A lot of you guys left one of these paragraphs blank, and then I couldn't give it to you. Okay? The other way you could have gotten that merit point is 2 substances positively identified reagents, observations, and equations. Now, I was nice, and I said I only required 1 equation, but if you had forgotten any of those things, like type of reaction or an equation, you might have answered 2 of them, but you haven't actually met all the requirements. The last one for the excellence then was identifying all chemicals correctly, discussing the reagents, conditions, observations, types of reactions, that sort of thing. And for this one, I wanted 2 equations. There were multiple equations that you could provide because each one had their own equation. The neutralization ones are always the easiest, so please just put those ones down for the litmus paper test one. The other thing to note about this, I'm trying to remember now, I wanted to say, oh, now I remember. Some of you guys went above and beyond for this one, for example, and gave me all the ways to test for an aldehyde. I can't give you more points for you giving me more reactions for that aldehyde question. It was just you needed to tell me 1. And you could see on the marking schedule, it was just you needed to actually identify the reagent for it, not just 1 repeated. So there wasn't extra points for giving me more answers. Make sure you answer all 3. That's how you got your points. Okay? So that's basically it. We have about 5 more minutes. I think that last question was pretty straightforward. Most of you guys got it really well. The only thing that was kind of an issue was that L. Remember, that was just their mistake, not ours. And I don't think there were too many mistakes with this last question here. You guys really own this conversion. You guys have been listening, and you know in order to move it, I need to make an alkene. Yeah, that was it. Well, because you guys have seen so many of them that you really know what to do in these guys. So yeah, that was basically it. That question 3, like I said, you guys did really well on. The main thing I saw for some people with question 3s, they did silly things. I had one person only give me 2 carbons, and for some reason just forgot these 2. And then I couldn't mark any of it right. So just count your carbons is my reminder for that. Awesome. Cool, I think that's everything then. Anything else? Questions, concerns, comments? I'm really frustrated. We pay for these exams, and then they're just riddled with mistakes.